Okay. So we've got a truss problem here. We want to find the reactions, or sorry, the bar forces in these three elements, AB, AC, and BC. So what I probably want to do first is find my reactions. I have 2 at a pin and 1 at C. So just to save a little time on the free body diagram, I'm going to go ahead and assume that my reaction here, I'll call it CY and assume that it's up. I'll assume AY is also up, and then I'll assume that I have an X force to the right. So if I consider this structure all, this is the free body diagram, I should be able to solve for these 3 reactions with my 3 equations. So I'm going to start, what do you want to do first? You want to sum forces in the Y direction first? Yeah, so we don't want to do Y because there's 2. We could do X, that would be an easy one to do. But at some point, you're going to have to solve moments. You can solve at A, you can solve at C. Probably A will be the easiest, so we'll start there. So I'll assume right-hand rule, and we will sum all the moment of the forces about point A and make sure the structure is in equilibrium. So what do we have about A? Well, we know AX and AY are concurrent at A, so they have no moment arm, create no moment. CY creates moment, and this applied force of 60 kilonewtons creates moment. So let's look at the applied force first. What kind of moment does it create about A with this sign convention? Negative. So we got negative moment. The force is 60 kilonewtons, and the distance from A to that line of action of the force is 10 meters. The next force we'll consider is CY. What kind of moment does it create about A using this sign convention? Positive, right? So have a positive moment, and the force is CY, and what's the moment arm? 5 meters. You guys don't want to play along today. So that looks like CY is going to be 120 kilonewtons. It came out positive, so it is up. So I'm going to now sum forces in the X direction. I'm sorry, Y direction. I'm going to assume up is positive. So I've got AY, that's up, so that's positive. CY, I assume that's up, so that's also positive. So AY plus CY. And then I've got this 60 kilonewton force down, so that's going to be negative. So what is AY equal to? Looks like it's negative 60. So what does that mean? The force at AY is opposite of what I assumed. So it's actually down. And that kind of makes sense for a second. If you think of C as a pivot point, this is like a seesaw, right? If I pull down here, I better pull down on that side to balance it out. Does that make sense? And then last reaction I have will be in the X direction. So I'll sum all my forces in the X direction. Make sure they're 0. I'll assume to the right is positive. AX is to the right. So that's a positive force. And, well, nothing else. So AX is 0. So now that I know my reactions and I'm doing method of joints for this problem, where should I start? Well, let me ask you this. Can I start at A? Yes. Can I start at B? Yes. Can I start at C? Yes. Why? Every one of those ones I've just mentioned, they all have 2 remaining unknowns. Now, it's your job to think, well, what's going to be the easiest one to do? B is going to be a little tricky because both elements are not aligned to the X or Y axis necessarily. If you look at A and C, you'll notice that AC is horizontal only. So that's probably going to be an easier place to start, either A or C. And alphabetically, I'm just going to pick A. So I'm going to start at joint A. Okay, here's my really bad joke. Here's my free body diagram. Are you ready? See, I told you it was bad. That's it. That's the body, right? It's just a point. What are the forces on that point? What's AY? 60. Is it positive or negative? It's down. So I'm going to draw it down. What's AX? 0. Nothing to draw. What's the force between A and C? Well, it's tension, right? All horizontal. The force between A and B, tension, has two components. Now I'm going to mark on here the rise over the run to help me do the geometry. So it looks like this structure has a run of 10 to a rise of 5. So that's a 2 to 1. So what would be the hypotenuse of that triangle? Square root of 5. 2 squared plus 1 squared. So that's not too bad. Okay, you want to sum forces in the x direction or sum forces in the y direction first? X? Well, if I do x, both my forces have an x component. I have one equation and 2 unknowns. That's not a good place to start. So we want to go y. So if you sum forces in the y direction, I'll assume up is positive. What do I have? Well, my force AB, the y component is up or down? It's up, so it's positive. What is the y component? That would be the 1 to square root of 5, right? Because the 1 is the vertical piece, the 2 is the horizontal piece. So 1 over the square root of 5 is the y component of AB, and that acts up, and then my 60 kilonewton force is down. So my answer for AB is positive, and it's whatever 60 times the square root of 5 is. What's that? $132.9, I'm guessing. 134? 134.2? It came out positive, so AB is in compression or tension? Tension. Now I can come back and sum forces in the x direction. Now you can see a disadvantage of this method is when I sum forces in the x, I'll have to get my new one, AC, but I'll have to use my old value. So if you mess this up, it's going to come along for the ride. So in the x direction, I have AC, which is positive. And I have the x component of AB. The x component is the horizontal one, that's 2. So this will be 2 over the square root of 5 AB. So I should be able to solve for the force in AC, which should be 120, but it's negative. Is that right? You put this value in here, multiply by 2, divide by the square root of 5, that should be AC, but the sign changes. Is that good? So let's see. I have 1, 2, 3, 4, 5. I only have one thing I don't know. What is it? Yeah, the force in BC. Now you can decide to go to C or B. I still don't like B because of all the geometry, so I think C would be the easiest one. So let's go do that. I'll spare you my sad joke about drawing the free body diagram. There it is. What's at C? Cy. Cy is 120 kilonewtons up, so I'll put that on there. I have a tension force from AC, and I have a tension force, I'm assuming, for BC. Just to remind you, I already have AC, right? So you can use either force. You can sum forces in the X direction, or you can sum forces in the Y direction. Which one would be the safer of those two? Yeah, if you sum forces in the Y direction, only BC has a Y component. So it'll balance here. You won't even have to worry about AC. So let's do that. Let's sum forces in the Y direction. Make sure it's 0. That particular element has a rise to run of 5 to 5 or 1 to 1. So the hypotenuse is square root of 2. So, It's a 45 by 45 theory. So the vertical component is up, and that would be 1 over the square root of 2 times BC. That's acting up. What else is in the Y direction? The 120 is also up. So when you solve for the force in BC, what do you get? It should be negative. I'm sorry, what is it? 170? Anybody else get that? Is there a point something at the end?
It's 169.7.
I like that better.
Okay.
169.7. All right, let's go back quickly and just do this. So AB is in tension. AC is in compression. BC is in compression. Does that make sense? Well, again, if you think of this as kind of a system balancing over that, as I pull down on both sides, right, these both compress and the top goes into tension. So that seems to make sense to me. Do you need to worry about that? No. But I think it helps you when you get your final results to kind of have a better feeling that you went in the right direction. Okay, sorry for going a little bit longer. You've been very patient. I appreciate that.